Already we have discussed about the conversion of the power supply from AC to DC. In this, the first step is rectification. What is this rectification? Changing the AC to the pulsated DC. This output waveform is called as a pulsated DC. Because in the original input waveform, you can observe positive voltages and negative voltages. But in the output waveform, only positive voltages are observed. And this is not pure DC. So this is called as a pulsating DC. We are taking the 230 volts 50 Hz input supply, 230 volts RMS voltage, and the 50 Hz denotes that the voltage what we are getting is repeating this cycle for every 1/50th second. For 1 second, 50 cycles are repeated. And this voltage is given to the primary winding of the transformer, and at the end of the secondary winding, one end of the secondary winding is connected to the diode, and through this diode we are connecting to the resistor. The second end of the secondary winding is connected to the resistor, and the diode cathode terminal is connected to the resistor. Here I am intentionally drawing this number of windings in the primary winding high, in the number of windings in the secondary winding are less, indicates that this is a step down transformer. Input we are getting 230 volts RMS voltage. Assume in the output we are getting 6 volts peak value. So amplitude is 6. Here this I am mentioning in the RMS value. Here this voltage I am mentioning in the amplitude peak level value, not in the RMS value. Okay, right. So here these two lines represent I am using iron core. During the positive half cycle of the supply, the terminal A becomes positive and the terminal A becomes negative. So during the positive half cycle, terminal A becomes positive, means the diode anode is connected to the positive terminal and the diode cathode is connected virtually to the negative terminal of the battery. So diode is forward biased. It simply acts like a wire, and the supply will be sent to the resistor. So whatever the supply we are giving in the positive half cycle, that supply will be received at the resistor, and the resistor is consuming that. So voltage. What is the current in the resistor? Because the resistor obeys the Ohm's law. Whatever the voltage signal shape is there, same signal will be observed in the resistor. If we are giving the square waveform, same square wave current is observed. If we are giving some triangular waveform, same triangular waveform current is observed. Because in the resistor, voltage is always directly proportional to current. Whatever the output voltage is observed in the resistor, in the same shape the current will be observed. Because one wave voltage here, we are observing the half wave. Only half wave is observed. During the negative half cycle, the terminal A is negative and terminal B is positive. Because the terminal A is negative, diode anode is connected to the negative terminal of the battery and cathode is connected to the positive terminal of the battery. So diode behaves like an open switch. Because diode is in open switch condition, there is no supply to the resistor. So from pi to 2 pi, instead of representing seconds, I have taken omega t axis. I am not taking the t axis. So I am representing pi, 2 pi, 3 pi. Signal 0 to pi, whatever the signal we are giving, whatever the voltage waveform, the positive waveform will be appearing across the resistor. In the pi to 2 pi period, because the diode is reverse biased, the waveform, the negative waveform is not appearing across the diode. So current is not observed during the period of pi to 2 pi. Because we are getting only half of the input waveform. So this rectifier is called as half wave rectifier. Out of the full wave we are getting only half wave, remaining wave we are not getting. So this is called as half wave rectifier.